All right, here we have this series problem from the 2001 AP exam. And they give us a series. It's an infinite series. We know that because of the ellipsis at the end. And they gave us the first three terms plus the general term. And the first question is, what is the interval of convergence? And we need to show the work that leads to our answer. So to do this problem, we have to set up the ratio test. So we're taking the limit as n goes to infinity, and then we want n plus 2 over 3 raised to the n plus 2 times x to the n plus 1. And then multiply that by the reciprocal of your original, which would be 3 to the n plus 1 times, divided by n plus 1 times x to the n. And then we can start our canceling. So x to the n plus 1 over x to the n will leave us with just an x in the numerator. And 3 to the n plus 1 over 3 to the n plus 2 leaves with just a 3 in the denominator. Then I'm left with n plus 2 times x over 3 times n plus 1. So my leading coefficient in the numerator is x, and my leading coefficient in the denominator is 3. Same degree, top and bottom. So my limit is the absolute value of x over 3. Now I need to set that in between I have to make an inequality out of it. So I'm going to do that by saying, okay, that means -1 is less than x over 3 is less than 1. Then I will multiply through by 3 on all three sides of the equation. And then the question is, do I include endpoints or not? So to find out whether I include endpoints, I have to go back to the general term, and I have to first plug in -3 and then plug in 3. So if I plug -3 in for x, I'm going to get n plus 1 over 3 raised to the n plus 1 times -3 to the n. Now, -3 to the n can be rewritten as -1 to the n times 3 to the n. So that enables us to simply cancel the 3 to the n over the n plus over 3 to the n plus 1. So I now have just a 3 in the denominator. So I'm now left with, let me see if I can write this out nicely. I have -1 to the n, which is an alternator, times n plus 1 all over 3. I think you will agree that if I did the nth term for divergence here and just took the limit as n goes to infinity, I would get infinity. So in fact, we diverge here, and we are not going to include -3 in our interval of convergence. Next, we're going to look at just 3. So I have n plus 1 times 3 to the n over 3 to the n plus 1. And I can easily cancel 3 to the n here with the entire exponent there. So I'm left with n plus 1 over 3. And once again, I can use the nth term test for divergence to show that the limit of n plus 1 over 3 is infinite, so we also diverge here. So my final interval of convergence does not include endpoints. Now, part B says, find the limit as x approaches 0 of this expression. And the most important thing to notice about this is that you plug in all of f of x first, and this is all of f of x. So we're going to take the limit as x goes to 0 of, and then we're going to write out, that's 3 squared plus x. We're going to write out several terms and the general term. And then we're going to, that's plus, plus, plus. Then we're going to subtract off 1/3 here. So minus 1/3. And then we're going to divide the whole thing by x. What you should notice is that my constant term of 1/3 cancels out with that 1/3, and that every term left in here has an x in it. So by dividing by this x, I just have to decrease by a degree. So I'm left with the limit as x goes to 0 of 2 over 3 halves, and now that x is gone, plus 3 over 3 cubed, now just to the x, plus n plus 1 over 3 to the n plus 1, and now x to the n minus 1, And if I take the limit as x goes to 0, every single term with an x in it goes away. So my limit is just this. It is 2/9. Okay, so the answer to that is 2/9. All right, I'm going to grab the problem and take it to another page so we have more space to work. And I'm going to do C, which asks us to do some manipulation of our Taylor polynomial. And they're asking us to take f and now integrate it from 0 to 1. So actually, what I'm going to do is do that right up here. I'm going to integrate from 0 to 1 and put in a dx here. So when I integrate, I get some constant of integration. Actually, I don't need that. It's a definite integral. So get rid of my constant of integration. I will have 1/3 x plus, and when I go up a degree in the x squared, this 2 goes away. So I'll have x squared over 3 squared. When I go up a degree in the x cubed, that 3 will go away. So I'll have x cubed over 3 cubed. And then I'll have my general term will be n plus 1 times x raised to the n plus 1 over 3 to the n plus 1. And of course, I have to divide by my new degree, which makes these cancel. And of course, then I have a dot, dot, dot. Now I have to evaluate that from 0 to 1. So if I plug in the 1 first, I get out 1/3 plus 1/9 plus 1/27 plus 1 over 3 to the n plus 1 plus dot, dot, dot. And when I subtract out, evaluating this at 0, notice that every single term has an x in it, so the 0 goes away. So the first 3 non-zero terms and the general term are these terms that I've written here. Then they're asking us to find the sum of the series. Now you only know there are 2 types of series that you can actually find the sum of, geometric or telescoping. So if they're ever asking you to find the sum, chances are it's going to be a geometric because we just don't see telescoping on the test. I look at this and I see a geometric with an r equal 1/3 and a first term equal 1/3. And my thing's not writing. Let's see. Doesn't want to write for me here. Nope, not going to get it to write. Okay, so let's see if I can pause it and fix it. All right, it was just delayed in its writing, so let me clean it up now. I have a sub 1, my first term is equal to 1/3. So my sum will be the first term over 1 minus the common ratio. So 1/3 over 2/3 is a sum of 1/2.